Okay, so this is Chemistry 2019 May, and I was asked to do this. So it says Michael and Jennifer were assigned a group project to investigate the effect of surface area on the rate of reaction between zinc metal and dilute sulfuric acid. They obtained 6 different grades of granulated zinc. The grades represent this average size of the radius in microns of the granules. The 6 experiments were carried out using the different grades of zinc granules, which were reacted with an excess of 0.5 mole cubed dilute sulfuric acid at 25 degrees Celsius. So I'm going to underline this and this. The same mass, 0.55 grams of zinc granules, were used in the experiments, and the time taken to collect 100 centimeter cube of hydrogen gas was noted as shown in table 1 on page 6. So that's a lot to swallow. So now it says, Figure 1 shows the stopwatch readings of the time taken to collect 100 centimeters cubed of hydrogen gas for experiments 1 to 6. So I'm going to just make this a little easier to do by using a ruler. I'll align it with the ruler and just find it here. So this is 11. This looks like it's smack dab on 20. This is 20. Smack dab on 31. And then we have here this looks like it's in between, so that's 41, 2, 3, 43.5. And then this one, let's see. I want to go along the line. So this looks like it's 52. And then this one looks like it may be in the center. So this might be 6, 7, 8, 58.5. So those are the times right there. I'm going to write them in. So we start off with 11. We write 20. 31. It's so easy it is to just write it down and then just flip over. 43.5. 52. And 58.5. So pretty much we have all of that. And then it says to calculate the rate. The rate is per second. Per second means 1 over s. So you would have taken the time and divided 1 by that time. If you look, you want to make sure it's correct. You say 1 divided by 11. Yes. And they look like they want just 3 decimal places. So I'm going to say 1 divided by 20, 0.05, 0.050, 1 divided by 31, 0.032, 1 divided by 43.5 equals to 0.023, because this will bump up that. And then 1 divided by 52, 0.019. And then 1 divided by 58.5. That will give us 0.017. So pretty much we have that. Just making sure that checking on my actual sheet that I worked it out on. Okay. Alright. Okay, looks like it's correct. Then it says, from the stopwatch is displayed on figure 1 on page 5. Record the times for the hydrogen gas to be collected in column 3 in table 1. and the time taken for experiment 1 has already been recorded for you. That's 3 marks. This is using the formula rate equal to 1 over time. Calculate the rate of the reaction for each experiment and record these values to 3 decimal places in column 4 of table 3. So we did that. The rate of reaction for experiment 1 has already been calculated for you. And then this is using the grid provided on page 7. Plot a graph of rate versus time for experiments 1 to 6. Draw the best curve through the points. So using these, we're gonna now plot the graph. And it was so nice this year. What they did, they gave you, they calibrated the graph for you. So we know at time at 11 minutes, so every 2 is 1, 11, 12, is it? No, it's 11, 12, 13, 14, 15. Okay, every one is 1 point. 12, 13, 14. Okay, so at 11, the rate is 0.091. So 0.09, that's 0. Oh, so it's all the way up here. 0.091. Yeah. And then we have at 20 is 0.05. At 31 is 0.032. This will be 1, 2. At 43.5, so we have 43, 1, 2, 3, and then here's 5. So at 43.5, 0.23. 1, 2, 3. So in between here, so 0.23, 1, 2, 3. And then we have at 52 is 0.019, 52 right here. And then at 58.5, 59, 58. So in between here is 0.17. This is 5, 6, 7. Somewhere there. And then I'm told to find the best curve. I'm going to give this a title. I'm going to say rate versus time in seconds. I'm going to draw the best fit curve that I could possibly generate. Yay, I did a good job. And so that's the curve right there. And as we turn the page, it says based on the graph plotted on page 7, deduce how the rate of reaction varied with time. And for this is a lot of comprehension, so to save time, I'm just going to refer to my answer sheet. I'm going to say what I have. So I said the rate of reaction decreased over time as the size of the zinc grade increased. Then, as explain how the trend in the rate of reaction stated in B1 relates to the surface area of the zinc granules. The greater the surface area of the zinc granules, the lower or slower the rate of reaction. Then it says list 3 factors other than surface area that affect the rate of reaction. And it would have addition of a catalyst, pressure, concentration, the nature of the substance. So all of that. And then it asks, state one safety precaution that Michael and Jennifer may have taken during the experiments. The same brand of zinc used should have been, so the same brand of zinc should have been used throughout the experiment. Also, reaction time should have been paid close attention to. Should have been paid close attention to. And then it says, suggest one way in which Michael and Jennifer may have controlled the temperature during the experiment. So they may have used a styrofoam cup with a styrofoam cover, no, with cover complete with a peephole made of cellophane, right? So we have a styrofoam cup with a cover, styrofoam cover, and then maybe like a peephole, a small peephole with cellophane so they could see what's inside. It could be on the side, could be on top, something like that. They could have done it like that, right? All right, so that's that for those questions. Then it says write a balanced chemical equation including state symbols, right? I need to do it. Okay, so balanced chemical equation, here we go. Zinc metal plus the sulfuric acid H2SO4 aqueous to produce zinc sulfate plus hydrogen gas, right? Good. So now it says calculate the total volume of hydrogen gas that would be produced at RTP from 0.55 grams of zinc granules. So here we go. We know theoretically 1 mole of zinc has a mass of 65.4 grams. Therefore, X mole of zinc would have 0.55 grams. So if you if you cross multiply, you will see that X is equal to 1 mole times 0.55 grams divided by 65.4 grams. And that will give us 0.00841 moles of zinc. Okay? So theoretically, if 1 mole of zinc reacts to give off 1 mole of hydrogen gas, then 0.00841 mole of zinc will produce X moles. And since it's a 1-to-1, it will be the same. Therefore, X is equal to 0.00841 moles of H2O being produced, of H2 being produced, right? So hence, if 1 mole of any gas occupies 24,000 centimeters cube of space at RTP, then 0.00841 moles of gas would occupy X centimeter cube of space. X would therefore equal to 0.00841 moles times 24,000 centimeter cube divided by, yes?
Sam.
Yes?
Okay.
It will equal to 201.8 centimeter cube of H2. I hope this is what you got. This was for 3 marks, so you just had to relate it. Okay? And I think this was the end of question 1. Then moving on to question 2. These are also comprehension questions, so in the essence of time, I will just read the answer sheet. So it says, Table 2 lists the chemical symbols of elements in period 3 of the periodic table and their respective atomic numbers. And we have sodium right across the argon. It says, explain why these elements are all placed in period 3 of the periodic table. I said, each of the elements have 3 energy levels which are occupied with valence electrons, right? Or with electrons, but it's all valence electrons going across here, right? With valence electrons. But each of them have 3 shells. And then it says, which element in table 2 forms an oxide which readily dissolves in water to give a solution with a pH greater than 7? Write a balanced equation to support your answer. I picked sodium, and I made sodium and oxide react with water to give sodium hydroxide. Balance. Then the element sulfur can exist as different allotropes. Define the term allotrope. Substances which are physically different but chemically the same. Okay, so that should have given me an answer. Then it says draw a diagram to show the arrangement of electrons in sulfur. And if you look at it, sulfur is in group, it has an atomic number of 16, as you can see here. Atomic number 16, which means that it has 16, in its ground state it has 16 electrons. So we're going to start sulfur, right? And pretty sure this is sulfur, right? So we know the mass number of sulfur is 32, so it has 16 protons, 16 neutrons, and the first shell can hold a maximum of 2, and we just keep minusing. So 16 minus 2 leaves back 14, and so 8, the next shell can hold a maximum of 8, so we just fill it out accordingly because we know we have 8 there. So we just minus 8, and what's left from 8 is 6, right? So this outer shell can hold more than 6, so we just say 1, 2, 3, 4, 5, 6. So it has 6 valence electrons, and guess what? It has 1, 2, 3 rings, and this is the nucleus. It says state. Okay, so it says state the type of bond that forms when sulfur reacts with chlorine. So remember that sulfur is a nonmetal, and chlorine is also a nonmetal. So together they're going to form a covalent bond. Then it says explain why the type of bond stated in E1 is formed. It says both, so I'm going to read what I have here. Both sulfur and chlorine are nonmetals. This means they will share electrons when they bond. Both elements are close enough to achieving their octets, where sulfur only needs 2 more electrons and chlorine only needs 1. Then it says write the formula of a compound which is formed when sulfur reacts with chlorine. And we have Cl2, the gas, plus sulfur, which is solid, to give sulfur chloride, which is solid, and it's balanced. Then there's a draw a dot and cross diagram to show the bonding in the compound stated in F. So I'll do it for you if you don't. So here is our little space. So I'll just say sulfur is sharing. So sulfur has 6 electrons, 2 of which are unpaired. And so chlorine, which has 7, will pair its one that is unpaired with that one, and we just fill it in accordingly. Same thing here. Right, so we have that, and that is that. Now we're on question 3, and again, in the essence of time, since I've already written it down, I'm just going to read it to you. So it says, polymerization is an important industrial process used in the manufacturing of many useful materials. Define the term polymer, a compound made up of many monomers. Then it says distinguish between addition polymerization and condensation polymerization. Addition polymerization involves the bonding of many alkene units, whereas condensation polymerization involves the loss of water or other molecules like HCl, I think NH3, but mainly this one. Then in figure 2, we have an illustration of the formation of a polymer. We have a diacid with an amine, and so we have water coming off. So it says state the type of polymerization represented in figure 2. It's condensation, and it's the formation of a look like a peptide bond. This is a peptide bond right here. Yeah. So it's condensation, and it says give an explanation for your choice in B1. I said water is lost or produced in the process. It says identify one use of each of the following types of polymers. Polyester, you see this on your clothing tags all the time. 100% polyester, 90% polyester, and then you see 10% spandex. So polyester is made in clothing, and polyalkenes used to make plastic bags and ropes and all of that. And again, we have some more, so I think I'll just go through this paper, just eliminate most of the writing. Figure 3 shows the fully displayed structural formula for compound A and B. And we have compound A right here and compound B, and the things that are different are the functional groups. So from the start, we know that this is an alcohol and that this is a carboxylic acid. And that's the first question they asked. They said, state the homologous series to which compound A and B belong. Compound A belongs to the alcohols and compound B the carboxylic acids. It says state the name for compound A. It has 2 carbons, so the name of it is ethanol. Compound A and B react to form compound C. Sketch the fully displayed formula for compound C. So this part here, this part would react with this part, right? And so you're going to form something like an ester, which is an ester. So this is a special bond here, ester bond. And we have the alcohol part here. This is the alcohol part here. And this is the acid right here. Okay, so it's fully displayed. You didn't need to do all of this, but this is how it is. And the name of this is ethyl propanoate. I think they asked that, or they didn't. Then they said identify the homologous series of group C. Once you see this special little bond here, we know that an ester is being formed. And once the acid reacts with an alcohol, in this case, an ester is being formed, or has been formed. State 2 other types of reactions that compound A can undergo. So remember that compound A is an alcohol, so it could definitely undergo oxidation. It could definitely undergo dehydration, right? So those are the 2. Moving on to question 4. You are provided with 2 identical samples of white powdery substances labeled D and E. One sample is finely ground sodium chloride and the other sample is finely ground diamond. Describe one simple test, including the observations, which could be used to distinguish between D and E. You could simply add water to both D and E and the salt would dissolve while the finely ground diamonds would not. Then it says sketch a unit cell of sodium chloride. Remember that you could start out with sodium or the chlorine atom, and so each of them have 6 units attached to them. So you could start with this chlorine and you form 6 bonds. Sodium, and sodium will be all these other balls, right? So those 6 bonds. And then it gets kind of confusing after that, because you want to think that everything else now that you attach will be chlorine. Pretty much after you do all that, this is how it's going to start looking. Or your text would have you draw some boxes, which I think is even more confusing. But whatever floats your boat, right? Whatever floats your boat. Because after a while, you can't even tell what's going on, right? So I just said sketch this. It's a sketch a unit cell of sodium chloride. I think this is pretty much enough. And it says state the type of bonding that occurs in sodium chloride. Remember, sodium is a metal and chlorine is a gas, so it will be ionic. That's 1 point. Figure 4 shows a part of the periodic table with some known elements and an unknown element X. It says magnesium, calcium, and the unknown element X react with water. Discuss the relative reactivity of magnesium, calcium, and X in water. Magnesium would be less reactive than X because its valence electrons would be experiencing less electron-electron repulsion than those of X. Calcium's reactivity would stand in the center. So this one will be more reactive than this because this is experiencing more electron-electron repulsion. It says write a balanced chemical equation for the reaction between water and the unknown element. So we know that X is in group 2. Water, we're going to form a hydroxide, and then hydrogen gas will come off, right? Yes. So this is pretty much it. Make sure you put your units, your states in there. Then it says element X reacts with oxygen to form a stable oxide. It's just a formula for this compound. So you have this XO2, XO2. Am I correct? No, I don't think so. Let me see. If it's magnesium plus O2, you get magnesium oxide. You have to put a 2 in front here. Okay, so my bad. So get rid of the 2. You have to put a 2 in front here. So see what I did? You make sure that you do it with something that you know. And then you make sure it makes sense. Good. So that makes sense. And you get a solid. If you ever burn magnesium in here, you're going to get a beautiful white bright light, right? So this is pretty much how it should be, because remember magnesium is in group 2. So when it blends with the oxygen, when it reacts with the oxygen, these two are going to cancel out to give you MgO, and then of course you balance out everything else afterwards, because the oxygen will be reacting as oh god, I'm losing my words, as a diatomic molecule, right? So it says state whether an aqueous solution of this compound will be acidic or basic. Give one reason for your answer. It would definitely be basic, as it is a metal oxide, and yeah, it's a metal oxide. So basically, metal oxides are basic. So it will produce a hydroxide. Yep. So it says state one test to determine if an aqueous solution of this compound is acidic or basic. You can use moist litmus, either blue or red. If it stays blue, then we know it's alkaline. But however, if the red litmus paper turns blue, we know it's alkaline. So I didn't finish my thought here. Then you could also use a pH meter. 1 to 6 states it's acidic, 8 to 4 basic, and 7, of course, is neutral. 5. Methane is the first member of the alkane homologous series. Lists 3 general characteristics of a homologous series. They have the same general formula, similar chemical properties, and similar physical properties. Write the molecular formula of the second and third members of the alkane homologous series. Is C2H6 and C3H8, and you just use the general formula CnH2n plus 2. So if I say C2, I know that's 2 times 2 is 4 plus 2 is 6. If I say C3, 3 times 2 is 6 plus 2, 8. That's how I know. It says derive the general formula of the alkane homologous series, and this is just general knowledge. CnH2n plus 2. Then it says 1-butene belongs to the alkene homologous series and exhibits structural isomerism. Determine the term structural isomerism. Same molecular formula but different structural arrangement of the atoms. Draw a fully displayed structural formula of 1-butene and its 2 isomers. So I did 1-butene, of course the double bond will be on the first carbon right here. You just make sure all of the carbons have 4 bonds around them, right? So that's but1ene or 1-butene. And then it says the other 2 isomers, and I did this cis, as did cis-butene, cis-butene, and I did the trans-butene. So these are the same, and they have the same molecular formula. If you count the hydrogens, you'd realize 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Same thing, double bond in it. 1, 2, 3, 4, 5, 6, 7, 8. So yes. So this is a cis because the hydrogens are on the same side, and this is a trans because they're on opposite sides. Then 1-butene, like all alkenes, are described as unsaturated compounds and undergo hydrogenation reactions to become saturated. Define the term unsaturated, highly reactive. State what is meant by a hydrogenation reaction, breaking of double bonds by hydrogen gas. Draw the fully displayed structural formula for the hydrogenation product of 1-butene. The double bond will break and you will have a splendid molecule of butane. Right? They didn't even ask. Did they say name it? No, but if you're feeling bougie, you could name it. Yeah. Then we should. Question 6. Metal alloys are often used in place of metals because of their enhanced properties. Define the term alloy. Alloy is a mixture of 2 or more metals. Name one alloy of aluminum and state its use based on one of its enhanced properties. And duralumin. Enhanced property strength. Use of alloy, cars, building of cars, car bodies, plane bodies. Then says a student conducted an experiment to investigate the reactivity each of the following metals: copper, iron, zinc, and lead, by using solutions of their sulfate salts. The data represented in Table 3 shows whether a visible chemical reaction took place when each metal was added to the 4 sulfate solutions. So visible chemical reaction took place is ticks, and no chemical reaction taking place is X's. And so we could see here that copper is very unreactive. It didn't react with anything, right? Zinc is the most reactive of all. And then we have next in line is iron and then lead. So we could already put them in order: zinc, iron, lead, and then copper. And we already know, please send Charlies, monkeys, and zebras in large high cages, so we done correct, right? So this is the order. And the ask, this is state which of the 2 metals is more reactive, iron or zinc. Give a reason for your answer. Zinc because it displays iron in FeSO4. That's what you could also put zinc because zinc had more reactions between the sulfate solutions than iron. You could have said something like that too, but this one would make you sound more like a chemist. It says, using the data in table 3 on page 22, deduce the order of reactivity of the four metals, copper, iron, zinc, and lead, from the most reactive to the least reactive metal. And just like I did over here, from looking at the ticks, I just put them in order. So zinc, iron, lead, copper, and I put them here, zinc, iron, lead, and copper, copper being the least reactive. The student recorded the following observations from the reaction between the iron and copper sulfate solution. Observations: reddish brown solid coating formed on the iron strip. Blue color of the solution changed to dirty green. Account for the observations made from the reaction between the iron and the copper sulfate solution. Iron reduced copper from copper 2 plus to copper. That's what was the reddish brownish color. Well, iron became oxidized to Fe2 plus, hence the color change from blue to dirty green. Write the ionic equation, including state symbols for the reaction between the iron and copper sulfate solution. So again, we went from iron to iron Fe2 plus, and then from copper 2 plus, which was in solution, to copper. So this was shiny, and then when it started reacting in solution, it became greenish, and this was blue colored. And when it started reacting, it started forming atoms coming out of solution to give that reddish brown color. And then finally, coming to the end of this test, some metal compounds are health and environmental hazards. Identify which of the metals used in the experiment in B is most hazardous to the environment, and it's lead. State two harmful effects of continuous exposure to the metal identified in C1 on human beings. It affects the normal brain activity, right? It slows or retards your mental capacity, and it's toxic to the body.